Hello everyone, welcome back to The Art of Engineering Efficiency Season 2, Episode 5. So far in this AI journey of mine, we have seen how a curiosity and a spark to start my journey in AI and explore various concepts in Python and language models. Today, we are going to see the next phase in the journey, that is building agents with language models with the basic tools that are available in the market. Langchain and LangGraph. If we have seen from the beginning in the previous demonstrations and the previous episodes, we have been building chatbot or AI assistant applications successfully without any external dependency. But what is the use of building agents? We can simply build agents with the help of language models plus Python code features. And we need to build lot of feature orchestration packages by ourselves to make the application work like a real agent by enhancing the application with the peripheral senses like image recognition, persistent storage, or voice conversions, or etc. Everything we need to build and we need to connect it to the application. That's how we did till now. But while exploring the LangChain and the LangGraph, what I realized is we have all these features packed within LangChain library or package itself. So it is we to decide which feature we need, initialize it with basic parameters, pass it to the LangChain initializer, which returns the agent. And from there, we can use the agent to execute multiple models. Each model is executing one tool, and all these tools can collaborate together and work for the agent. With this LangChain and LangGraph, we are going to enhance the power of AI in a more efficient way. This is a chatbot application which I built using LangChain. Here we have three examples. First will be retrieval QA. It's a basic document search application. Second one is a conversational chain application. And third one is a conversational plus retrieval chain application. First, we have this as helper. This is basically a wrapper class which I built to handle the documents on the launch, whether to load or save. In our earlier demonstrations, we did a small tweak like on first time launch, we saved the documents. On the second time launch, we commented the saved documents and we enabled the load documents. But in this example, we enhanced the logic, but it is entirely new. Let me bring up that as helper. The key functionality of this helper class is it will give us the FASS vector DB reference from the Hugging Face embeddings. Again, it's a part of LangChain, so we don't need to import any other package. Once we have the LangChain, we can import all the libraries from there. Once we initialize it, then it's a usual documents loading job that we need to take care, because LangChain doesn't deal with saving or loading the memories. It actually deals with the memory index, and it uses the data to set the context while processing the user inputs in the language model. So that's why we build this. So here we have manifest file as an additional feature. Every time when we load the documents, it compares the previous modified time and the current modified time, and if there is any change, then it will update the document. If there is a new document available in the documents directory, then it will update it. So that's the simple idea of having this helper class. So I don't want to overload this chain bot. That's why we have the helper class separately. We use it to load the vector database. That's very simple. By this step, the database is loaded with the documents which are provided in this document directory. So I have given two documents. One is the story and one is my professional profile. Here we need to initialize the language model. In our previous example, we have seen we installed ollama, and then we need to pull the language models in ollama. Then we need to explicitly run ollama to make the application work. Here in this case, we need to install ollama and then we need to pull the model whichever we want to run the language model with. But we don't need to import or we don't need to run the ollama here directly. So instead, we can import ollama from Langchain community. So this will internally takes care of running the ollama on behalf of us. Once the agent is initialized, then we'll run the language model using ollama. I have given llama 3.2, and over here we are creating the agent. We are using retrieval QA chain, which is available in the LangChain. From the chain type is a language model. Vector DB we are giving for database retrieval. Chain type is stuff, which is a predefined chain type from LangChain. Because I'm using small documents, my document size is very small, I'm using stuff. If we have bigger documents, we have other chain types as well, like refine or etc. So we can explore that part if we are building the bigger size documents. Now we have the agent ready. Let's run the agent now. So this is a simple conversational bot from the documents. So basically, if we have a document of your personal profile or someone's profile, you can put a lot of queries and understand about what is mentioned in the documents. I will introduce myself just for a formality. Hi, I'm Sandeep. How are you doing? This LangChain chatbot takes some time to execute the queries. So I think because I already shared my profile in the documents directory, it already has some information about me, and that's why it is able to reply me with some information which I already possess. That's what we can see here. Now let me ask a query about, can you describe my professional experience in short? I was saying like LangChain do take some time to execute our queries. Sometimes it takes more as the context become bigger. We got the response. Okay. Yeah, TPS that I have the professional experience in software development and leadership. It actually read the content from my document. So now, earlier in our previous episode, we did the similar kind of application, but that was purely built using Python plus language model. We did write code to actually parse the data from language model. We need to build the prompt, setting the context and everything that we need to take care. But using the LangChain, there is nothing we did. All we did is just we initialized an agent with the language model and the vector database. That's it. These are all for the coming example, so don't worry about them. This is the simplest way that we can create document search application using LangChain. Now we are done with this example. I hope you can explore it too. But one small thing I would like to add it here is whatever answers we get from this application, they are purely based on the intelligence of the language model, how they get trained, what kind of data set they have, how their embeddings weights are. If we use a different kind of model, we would get a different kind of response, and it varies how they improvise the context and share the similar facts from the documents. Let's go to example 2. So I'll comment this agent now. Example 1 is done, and for example 2, it's a conversational AI. This remembers what we say in the current session. This can be used where there is no need of remembering the customer charts like you chatbot applications, where the memory is specific to the session, and once the session is done, they won't be able to recall the previous conversation history. This is just like banking or customer support based chatbot kind of application. And remember this, for conversation, if we are using short-term memory for conversation chain, it expects memory key as history. That's why I commented here for example 2. Let's stick to that. And there is no need of template now, but I am not commenting it. So example 2 is ready. Let's quickly run the code. Now the conversation chain started interacting. So this is how, if we enable the verbose, we can see the logs within the LangChain conversation chain. So it said blah blah blah, something dramatic. It has explained in like a storytelling way. If we look at the code, we haven't given any kind of vector DB to this, so it won't be able to read any of the documents from us. So even if we ask something, can you it won't be able to recall anything from me. Accessing external information, that reading minds, so that it's clarified that it doesn't know me, but it can still converse with me. I will share my interest now. My interests: long rides, trying different foods, exploring tech. So again we can see complete log. I think it is thinking too much about sharing its personal interests. Yeah, that is right. I'm delighted to hear that, Sandeep. It sounds like. Okay, now let me ask, what are my interests? So let's see how it responds now, because this is purely from the conversation, so it should be able to recall what we just asked. That's it correctly. Now let's try to test whether it's able to recollect if the session is end. I'm restarting it. So the session is closed, the memory is wiped off. What is my name? It doesn't know anything about me, or it doesn't have any external data sources. That's why it can't help. Basically, it doesn't know about me. That's how the conversation chain works. Based on the use cases, like we discussed earlier, any kind of banking applications or customer support applications, they won't be able to persist the conversation which we had like a day ago or a 1 hour ago. So for those kind of applications, they can rely on this conversation chain. The conversation is purely based on the session. So let's go back and change the setting to chart history. If we don't change this, then when you run the code, then obviously you will see the errors that the conversation buffer is missing with the input keys of chart history or history. Earlier I faced this kind of errors and I struggled to understand these errors are because of this memory key. It was really great experience to understand these minimal concepts. That's why I documented here. When you are executing example 2, use history, and executing example 3, use chart history. So don't forget that. We have an agent. It's a conversational retrieval chain where it has access to short-term memory and a long-term memory from the vector database. And we comment example 2 and enable example 3. So basically for example 3 we need to do 2 more steps in addition. Like as soon as the conversation, the LangChain or agent returns an answer, we need to save it in our vector database. So this is where we actually store the conversation and retain it in our next session. So that's the only difference that we can see from the conversation chain to the conversation retrieval chain. And apart from that, I do like to explain here the input variables are chart history, context and question. So chart history and context will be taken care by the LangChain itself. They will pass the values while running the agent. So that's why we don't need to take care of those things. We don't need to manage or bother about them. We just need to simply pass the question from whatever user asked. This is the prompt template because we need to inform the conversation travel chain that we need a combination of answers from both chart history and the context. We need to explicitly mention that, otherwise the LangChain won't understand from where it needs to fetch the answer from, and sometimes it may say it doesn't know what we are asking for. That's why we pass the prompt here. The prompt holds this and the input variables and the template here. So that's all it has, nothing much. So let's run this now. We cleared previous cache. So I'll reintroduce myself as hi. It fetched from the actual context. It identified who I am because I have already shared my profile in the documents. It do have context about me from the context. So let me share my new interest now.
To share my interests, going on long drives, trying different foods, and exploring tech. Okay?
Same conversation that we did previously. Let me put this in a question way. So if I make it like a question at the end, the bot is actually responding in a positive way. So that's one observation that we can clearly see here. It said information that I shared in the conversation history, but it was not mentioned earlier in the context. Okay, let me quickly exit now. I will end this session. Let me restart the session so that we can test whether it remembered what are my interests shared in the previous conversation history. I'm directly asking it without asking any other questions so that we can wrap this demonstration. Okay, let me ask, what are my interests? You mentioned earlier that you enjoy going on long rides, trying different food and exploring tech. I'm not aware of any information about Sandeep Kumar's interests. It recalled the conversation, but it didn't map from the document's context, conversation context. That's why it didn't answer here, but it is able to answer what are my interests if I ask. Now I ask what is my name. So we can clearly see now we are able to recollect the previous conversation history using the conversation retrieval chain. Using this we can build like a chat GPT application which runs on persistent memory to provide conversation history even from long times. Initially first we got the LangChain where the orchestrated features were boilerplate packages are available for the developers, which reduce a lot of copy paste code duplications. For me, from my previous experience, this is almost same to any other domains. Like if we take a back and front end, we already have well standard sophisticated architectural practices. I see it is a bit similar, so I can relate the concepts with my previous experience. So that's how I saw how this LangChain and LangGraph architectures are there. LangChain is kind of a linear workflow. I mean, if we are building any simple like a 3 to 4 steps, if there are no dynamic routings, easy to manage kind of workflow, then we can go for the how we can build a content writer bot. In the LangChain workflow, we are going to interact with multiple tools and each tool uses separate language model. All these tools collaborate together and work on the user's input to generate the final article. So that's what this application is about. Let's see what are the internal blocks of this application. This is a workflow bot. So I'm using Tavily search results to get the latest news, and this is one of such result which I hard coded here because I don't want to run out of my tokens as part of the experimentation. So I hard coded running locally all the operations. I'm having the reference of three different language models, Llama, Mistral and DeepSeek, and we will be using each language model to execute a different task in this application. So let's go to the initializer part. So let's go to the initialization. While you are experimenting, you can actually create an API key and give it here so that you can get the live data from the API results. This is a publisher tool. So once we have everything, so this will take and publish the things to the external sources. I mean, if it is needed, we can have it. Because I don't have it at the moment, I left it empty. But this is an ideal execution scenario that we can make use of it. That means we can directly publish to our blog posts or websites, or even we can send emails. All these can be executed using this publisher tool. And then we have the language model references, and forget this part. This is hard coded and this is just content. The initialization is done. Let's see the workflow chain now. So the user input will be received as part of the chart to this workflow chain. Step one is we have created a research tool where it needs to perform the research. Let's go to research chain. Ideally, this is how it should work. So this is the research prompt and it tries to get the topic from external sources, and then this is the chain that does the actual researching. So it takes the topic and it actually get the results from this lambda function, the travel run topic. So it passed that topic and it directly converts, because we are using an internal library of the LangChain for the Tavily search results. So it actually reformats LangChain's data structure from whatever the API is returning. Once we have the topic and results right, then it construct the research prompt and then it will hand it over to the LLM. That's the job of research chain. So I got this data likewise during my experimentation and I cached it for the demonstration purpose. Once we get the data from the research chain, whatever content which is derived from the research chain is handed over to the validator chain. Validator chain is something which runs locally and using an LLM, using llama here for this purpose, and the chain goes like this. And it needs a validator prompt and the language model instructing this chain to generate the content without grammar issues and without any tone mismatch or avoiding hallucination. If there are any factual errors, we're giving the content here to validate it. So the model validates the content based on its personal knowledge. But if we have any facts to validate the content, we can actually inject it here in this prompt itself by mentioning it as a facts. Compare the content with the actual facts given like a placeholder, something like this. So we can mention this and we can give it as an input in the validator chain. So here we have given input content, right? So similarly, we can give as fact and whatever object we have for the facts from either we retrieve from any documents or any external sources, we can fetch from that source and we can give that as a result here for the fact checks, because that will take too much time to execute the demonstration. So I'm not going into that direction at this point, but we can try it out and purely based on our personal interest. So that's how we created a validator chain. And once the validator chain is done, then after verifying all the facts, then we get a valid output. And now we are going to assign a different tool, different chain, to finally draft the article from the validated article. We are setting it like insights, format is article and tone as professional. So let's go to writer chain. All the chains follow the similar pattern of execution. So every chain needs an LLM. Here we are using a DeepSeek as a writer and instructing it to, using a research insights below these insights, write a format in tone. We are passing two arguments when we are executing by user input, format and article. So these will be accepted as a parameters while constructing the prompts. Only return the article, no analysis or internal thoughts. Otherwise, final article will be included with a lot of thought process of the LangChain itself. Because we don't need them, we are setting that as a rule in the prompt and instructing the language model not to include them. We have all the tools in place to execute the workflow now. So once after the workflow chain executes all the steps, then it will return the response and we can see the final response here. So let me execute this workflow now. Let's execute the workflow. In my earlier experimentations, I have observed LangChain. This workflow execution will take enormous amount of time. Let me see what I hard coded about AI in agriculture. How AI agriculture impact future. Okay, so this is my question. Because I have hard-coded input content, the research content is very quick. Otherwise, to perform this operation itself, it will take 3 to 4 minutes. It depends on our laptop's computational power again. I'll be forwarding the video a bit. I think the second one also went through. Validation output has come here based on the context provided. It identified a few grammar issues and tone mismatch it found, because we said it as professional, right? So it found that and it fixed it. Hallucinations not there, and factual errors, it found few things based on the language model's internal knowledge. Corrected version it returned. This is the final version from the validation output, corrected version. This output is handed over to the writer chain. Now the writer chain is executing. Let's see the output of writer chain once after finishing its job. The chain is taking too long. Here we got the final article, AI's role in modern agriculture, opportunities and challenges. This article basically consolidated all the facts and what are the technical advancements and how AI currently, how it is impacting and how it is going to impact in future. All the details are well articulated by this writer chain. So with this, I'm exiting now because trying any other prompt will again take like 5-10 minutes, which is not actually suitable for the demonstration. And I do add one point here. In various examples, I have noticed people do have a router chain. The language model decides which task to execute next, and sometimes we get repetitive actions even if the action is completed because language model instructed the router chain or router task to execute same action again. Workflow will not execute in a smooth way. All this happens because language model or LangChain doesn't remember what actions they executed or will execute. It is our duty to maintain the state explicitly and to control the workflow while executing these applications. That is one setback what I have seen while experimenting with the LangChain workflow. That is the reason why we haven't seen a router chain here, because I don't want a router to decide what action to take next, because we know what are the sequence of steps to execute in this workflow. And that's why we directly started with the workflow and started with the research and executed next steps in the sequence. This is clearly an example for LangChain linear workflow. That's how we can build AI applications by enhancing the power of LangChain. But if something more complicated comes into the picture, if we are building a workflow with multiple conditional routings, lot of retries, back traces, branching from one workflow to the other, I mean different point of the workflow, this also can be done using the LangChain, but it is very difficult to maintain the code. And as the application scales up, this kind of architecture becomes very messy and very hard to understand and very hard to enhance it further as well. So that's why the LangChain further evolved as LangGraph. They have built a LangGraph as a different package on top of LangChain itself.